Okay, so let's get started, okay? So great, we're here to talk about cryptocurrency, engineering and design. I think the first question that comes up that's very obvious is, what is a cryptocurrency? So this word was kind of invented 10 years ago when, I don't know how many of you know the origin story of where Bitcoin came from, but basically a pseudonym on the internet dropped a paper and some open source code in a forum on an email list and said, hey, I have this idea for this thing called Bitcoin. It's kind of like electronic cash. Here's how I think it could work. And here is some code if you want to run it and become part of this peer-to-peer network. We don't know who this person is. This person is basically virtually disappeared from the internet and from the world. But it's created something that has captured so many people's imaginations and has sort of, depending on how you measure it, created billions and billions of dollars of economic value and sort of inspired a lot of people to think about how to use this technology to solve a myriad of different problems, not just electronic payments. So, cryptocurrencies and the technology behind them are inspiring people to think about how to bank the unbanked, add more auditability and traceability to our world, get rid of trusted intermediaries and institutions in certain situations, and basically solve every problem if you read about what blockchains can do on the internet. Now, that's not exactly what this class is about. This class is not going to be about applications. This class is going to be about technology and infrastructure. You're going to learn how to create a cryptocurrency, what goes inside a cryptocurrency, what's important, what are the techniques, and what application you choose to apply that to down the line, that's kind of up to you. But we're not going to be doing digital identity or healthcare records or something like that. We're going to be talking about the technology. So a big question is, how are cryptocurrencies different from regular currencies? And another thing that I want to make really clear is that the terms in this space are still being defined. So you will hear people throw around all sorts of terms: cryptocurrency, blockchain, consensus, and these words are kind of have floating, evolving meanings right now. Part of that is because Bitcoin, the first cryptocurrency, didn't come from academia as far as we know. It came from a community of enthusiasts on the internet. And so it doesn't necessarily have the same basis and rigor that we might expect from most of our academic fields of study. It's totally okay. We're figuring it out as we go along. And academia is really embracing this topic. So if any of you are graduate students who are looking for an area in which to do research, I think basically the number of papers published on cryptocurrencies and blockchain technology in respected academic venues is doubling every year. So there's huge opportunity here. So cryptocurrencies are not regular currencies. They're not a dollar or a pound or a euro, what we normally think of as currency. There's something different. Bitcoin was sort of created out of nowhere. And what does it mean to create a cryptocurrency? Who says you can create a cryptocurrency? What backs a cryptocurrency? Why is it valuable? Well, I think first, before we answer that question, I just want to make it really clear what this class is not about, okay? We are not going to help you ICO. If you are interested in ICOing, just go. That's not what this class is going to be about. We are not going to offer any trading advice. We have zero opinions on whether you should buy Bitcoin now or sell or whatever, or Zencash or whatever all these things are. So none of that. Don't even ask us. We're not interested. And this class is not really going to be about permissioned blockchains either. Now, you might not know what this term means yet, and that's totally okay. But I just want to make it clear that what we're talking about here are cryptocurrencies. They're open, permissionless systems in which there is a token which has some value. So that's what we're not going to do in the class. So going back to, and let me just pause there for a moment. Let me pause and ask you if there are any questions so far about what I've said. Yeah?
Do tokens always have to have value?
No, not at all. And let's start to get into that. So the question was, do tokens always have to have value? So I think really to understand what are cryptocurrencies, what are tokens, what do they mean, we have to talk about money, okay? And we have to talk about what money is and what it means. this is going to be very hand-wavy and I'm sure not very satisfying to a real monetary economist, but money developed. There are a few different theories about how money developed. There is this thing called the coincidence of wants. So maybe I have a sheep and Taj has some wheat. I am hungry and would like to make bread. Taj would really like to make a sweater. And so we can barter, we can trade. I have one set of goods that is useful to Taj. Taj has another set of goods that are useful to me. We can get together and make an exchange. So that's fantastic. Barter is incredibly important. Barter's existed for a long time. But what if, Taj doesn't have wheat, Taj has vegetables, and I don't want vegetables, I want wheat, but Taj still wants the wool from the sheep. How do we execute this trade? We don't have a coincidence of wants. We don't actually want the exact same thing from each other. So some theories are that money evolved out of this problem, and money can be represented in so many different ways. It's from money. I think was first created around 5000 BC, so it's really, really, really old. The things that represented money usually had certain properties. They were rare. They were not easily reproducible. People at times used things like shells or beads for money. The first coins, this is like a really interesting coin that was developed. Precious metals were often used for money. And then eventually we sort of evolved into what we think of as money now, which is paper bills, currency. Another theory of how money came about is this idea of receipts, debt and credit. Maybe I have a sheep and I shear all of my sheep and collect a lot of wool. What I can do is I can store that wool somewhere. And I can get a receipt from someone from having stored that wool. And that receipt is of value. It entitles the person who holds the receipt to the good that is being stored. And so another theory of money is that money evolved out of these receipts, trading these receipts back and forth. Instead of taking all that wool with you, you leave it in one place in a depository, and the receipt acts as a bearer instrument. Whoever owns it has access to the wool in the depository. And so you can kind of see two different ideas about what money is develop from this. One is, well, it's a bead or a coin or something that I hold, something physical that we've decided to assign value to in and of itself. And another idea is I'm going to use a trusted institution. I'm going to deposit something with that institution, and they are going to ensure the validity of that deposit and manage who has access to that deposit. So this doesn't really get at the question that was originally asked, which is why do tokens have value? But one thing I want to point out is, why? Well, a question I want to ask you guys actually is, why do these things have value? Does anyone have any ideas? Yes.
Because everyone agrees that they do.
Because everyone agrees that they do. Any other thoughts on why those things have value? Yeah.
They're also backed by institutions like the government or...
They're backed by institutions. Say a little bit more about that. What does that mean?
So the government's kind of promising you to respect the value of that.
Okay, the government's promising to respect the value of that. Does anyone want to add to that or have another reason? Yes.
So.
And say your name, I'm sorry, yeah.
Jared.
Okay.
Jared Johnson.
Yeah.
In the example of the dollar, the government is willing to accept it as payment for taxes.
Payment for taxes. Okay, so that kind of connects to the government thing.
Even if it had no value in any other sort, it has value in that sense. So it's like the last thing that holds up its value.
Okay, great. Anybody else? Yes.
I'm Paul. I think those on the three on the front, except for the dollar, those have inherent value because they might be more rare. Right?
They have value because they're rare. Okay, interesting. All right. So those are all really interesting ideas. I think that those are all sort of properties of what makes things valuable. There are definitely things that are rare that are not valuable, right? I can think of some things, that might be extraordinarily rare. There's only one or two of them in the universe, and you would have no interest in owning them whatsoever. You wouldn't assign value to them. Certainly, it's really important that you can pay taxes with this stuff because taxes is pretty much a requirement of living in any country. There are things that have value that you don't necessarily use for taxes, so that's a little confusing. And then there's this idea that it's backed by something, right? The dollar used to be backed by something, and actually, if you look at a dollar, I think it still says this, right? It's backed by the full faith and credit of the United States government.
They don't say that anymore.
They don't say that anymore. They used to say that, but that's what like a lot of people say about money. It's backed by the full faith and credit of the United States government. What does that really mean? I think what it all goes back to is these things are valuable because we think they're valuable. We've all decided they're valuable, and you know that if you have a dollar bill and you want to buy something from someone, they're going to take it. That you can make that exchange. And the reason that they're going to take it is because they know that someone else is going to take it, right? These things hold value because we think that they hold value. It's a collective story that we all tell. So I think once you look at money that way, then when you start to look at tokens, which are essentially digital representations of these things that are rare and a little bit special, then when you ask, well, why does this token have value? Because we think it has value. So what makes a token inherently valuable? The fact that we think it's valuable. And a lot of different things can go into that. Maybe we think it's valuable because it's very rare. Or maybe we think it's valuable because someone's promised that you can use it to pay for storage, like with Dropbox. Or maybe we think it's valuable for a completely different reason, because we like the name, or we like the people who are running the network. But ultimately, tokens are valuable. These digital representations are valuable because we think they're valuable. Yes?
And also because they're limited,
Name.
no?
Which-
Okay.
Okay.
Okay. Because they're limited, no?
My argument is that the fact that they're limited is something that goes into our perception that makes it valuable. Great. Okay. So now that we've learned a little bit about money, we've talked a little bit about money, I want to go into how payments work, because ultimately we're going to get to cryptocurrencies, and cryptocurrencies are electronic cash. So here's the way that digital payments kind of work right now. You have an institution called a bank. You have Alice and you have Bob, and Alice and Bob have accounts at this bank, right? And so the bank is keeping track of sort of who owns what. And these are records. These might be digital records, they might be paper ledgers or paper records, whatever the bank is using to keep track of sort of who has what in their account. And so the way that I've set up this example right now, Alice and Bob both have bank accounts. Alice has $10 with the bank, and Bob does not have any money with the bank. So let's say that Alice wants to pay Bob. Let's say that Alice and Bob have gotten together. Maybe they're in the same coffee shop, and Alice wants to buy a sandwich from Bob. And Bob says, okay, you need to pay me $1. If you give me $1, then I'll give you this sandwich. So how can Alice do this? How can she transfer $1 to Bob? Well, if she had a paper dollar, she could just do that, right? But let's say that she doesn't have a paper dollar. So Alice can ask the bank to make this transfer for her, or $5. So Alice sends a message to the bank and authenticates with the bank, and to show the bank that she is in fact Alice, but I'm not going to go into the details on how that works. And then the bank confirms that, makes the transfer in its ledger, says Alice now has $5 and Bob now has $5. Alice tells Bob, hey, I did this. I talked to the bank. Go check. You can verify it for yourself. Bob checks with the bank and sees, yes, in fact, the bank is saying that he has $5 now, whereas before he had $0. And then Bob gives Alice a sandwich because he believes that he now has $5. And the bank sort of preserved the property that money was not created out of nowhere, that the balance was ultimately maintained. So the bank is very important in this scenario. The bank is critical. This is how digital payments work. Credit cards, Venmo, banks, it's kind of all sort of based on the same idea that there's some trusted institution that is handling that payment for us and that is keeping track of everything. Now, what are the pros and cons of this scenario? Anyone want to throw a couple out? Yeah.
The bank could get hacked and people can move money around between the accounts.
Right, so we're putting a lot of trust in this bank, and maybe, should we trust the bank? Banks fail sometimes. Banks are hacked. Banks have humans who are running them who occasionally might want to change those balances in their favor. This has all happened. Anything else? Yeah, and see your name, please.
Brittany, if it's urgent, sometimes you might run into a delay or, it might take time to process.
Yeah, there's a lot, Alice has to talk to the banks, and that's kind of annoying. So there's that. Anything else? Yeah.
And if everyone could actually withdraw at the same time and the bank could actually have their money in the system.
So, okay, so this is like getting a little bit more advanced here. What if everyone takes their balances out at the same time? Well, we need to make sure that the bank actually has that money, so to speak. We're not going to be talking about that problem right now, but very good problem. So to kind of talk through some of the pros and the cons of this situation, one of the big pros, I think, is that even if Alice and Bob are not in the same physical location, Alice can still pay Bob if they can talk to the bank. So that's pretty cool, and that's something that you can't do with dollar bills or with coins or with bars of gold, right? So having this trusted institution that you can communicate with electronically means that Alice and Bob could be halfway around the world from each other and they can still pay each other. So that's pretty awesome, and that is definitely a property that we want to have. In terms of cons, I think we covered quite a few of them, which is, we're really putting this bank kind of in the middle of everything here, and there are a few different ways that can cause us trouble. So the bank needs to be online during every transaction. If the bank is offline, then how does Bob know whether he got paid or not? The bank could fail at some point in time, which is kind of related to that. The bank could simply decide that they don't want to do this anymore and can block transactions. And then privacy. The bank has kind of insight into everyone and their payments, and this is like incredibly sensitive information. Payments are quite important, and we're going to be talking about privacy a lot in this class, during the second half of this class. So just like an example, a couple of like visual examples of that, the bank could just totally go away, and then what happens to that ledger? Who knows, right? I mean, literally, it could just disappear. It's just, maybe it's paper and it gets burnt, or maybe it's bits on a computer and it wasn't replicated. The bank could decide that they don't like Alice for some reason and that they don't feel like processing Alice's transactions. This happens all the time in the real world. So there have been designs for electronic cash that work a little bit differently. And we're going to kind of step up to the most sort of like the design that came right before Bitcoin, and we're going to do that iteratively. So let's talk about eCash and how eCash works. So the way that eCash works is Alice tells the bank, instead of saying, hey, bank, do this transfer for me, Alice says, hey, I would like a digital representation of a coin. Can you give me something that is digital, so I don't have to be in the same physical place as you, and that, that I can use in such a way that I can prove to someone else that I have this thing and that I haven't double spent it. Because that's the problem with digital representations of coins. Like a fundamental problem is that bits can be copied. So whatever system you use to design your electronic cash, you need to make sure that people can't just copy coins and give this what is sort of the same coin to multiple people. In the previous example, the bank was making sure this happened. The bank was maintaining balances and debiting Alice's account and crediting Bob's account. But if we want to think about something that doesn't involve the bank, and we're starting to get there, then we need to think about how to ensure that a coin can't be what is known as double spent. So Alice asked the bank for a coin, and maybe she does it. Maybe she has an account with the bank like before, or maybe she gives the bank teller like actual physical money in order to get one of these coins. So the bank generates a unique number. SN stands for serial number, and decides that this is the digital representation of the coin. The bank then gives that coin to Alice in a way that it's clear that the bank did this. Usually this is done using a technique called digital signatures. We're going to get to that as class progresses, but not right now. Once Alice has this coin, then she can give it to Bob. And Bob can take a look at this coin, and hopefully there's enough going on with this coin that Bob can be convinced that this is a real coin. Alice didn't make it up out of nowhere. She actually had the funds, so to speak, to give to Bob, and that it hasn't been double spent. And with traditional eCash, the way that this was, and once Bob is convinced of that, he can give Alice the sandwich. Now in traditional eCash, the way that this is done is Bob actually goes back to the bank and says, here's this coin. Alice just gave me this coin. Is this an okay coin? But the fact of the matter is that the bank in this case has a serial number and knows that it gave that unique serial number to Alice, and then Bob is showing up with a coin that is that serial number. And what the bank is doing here in this example is the bank is, the way that the bank checks to make sure that this coin is correct is it looks at the serial number and it makes sure that it hasn't been spent before, right? So the bank can link the coin between Alice and Bob, which is unfortunate. The bank also kind of still sort of has to be online, not to do the actual payment between Alice and Bob, but in order for Bob to have confidence that this coin is real. Later on, Bob can say, I would like $1 for this coin that I've just given you, or something like that. Or Bob can have an account with the bank and can maintain a balance there. So just to kind of like go through some of the pros and cons here, okay, we've kind of done something where the bank's not in the middle, except the bank is still really in the middle. We're getting like a step closer, but we're not there. We don't need, Alice can technically give Bob this electronic thing that represents value, but Bob still needs to talk to the bank to make sure it's real and it hasn't been double spent. And we still have this problem where the bank is the one who's minting these things. The bank can decide not to give Alice a coin if it feels like it. And we still have this privacy problem because the secret number, the serial number that we invent for the coin can be linked across these payments. There's this notion of something called Chaumian eCash. So David Chaum is a cryptographer, and he developed this system which has slightly nicer properties than previous forms of eCash. So the idea here, that's really key, is instead of the bank choosing the secret number, Alice chooses the secret number. And we have ways of generating random numbers that we can be fairly sure are unique. So we can let everybody generate their own random numbers. So in Chaumian eCash, Alice chooses the secret number that represents a coin, and then Alice blinds her message. So Alice adds some randomness to the secret number such that the bank doesn't know what that number actually is. And we'll get into more detail about exactly what that means. That's actually, it's all in the paper that was assigned reading for this class, so make sure that you take a look at it. So when the bank verifies that this secret number is a real secret number and it's really a coin and Alice gave the bank $1 or something like that, the bank does so on the blinded secret number. And Alice actually has the ability to remove that randomness or that blinding later and end up with a valid signature on a secret number. So Alice does the same thing that she did before. She gives Bob a representation of that electronic coin. And when Bob redeems it, note that the bank never sees what the number is. So when Bob redeems it, the bank has no way of linking the payment between Alice and Bob. So just to get into how this works visually, Alice will talk to the bank, and Alice will use a blinding factor on the secret number. And so when Alice talks to the bank doesn't actually see what the secret number is. They can't decode it. Again, Alice gives $1 or something like that to get this coin from the bank. And the bank signs this. Alice can remove the blinding factor later. And this is what the coin is. The coin is a valid bank signature on the secret number, and also the number itself, which Alice can then send to Bob. Bob can check and make sure that this is a valid signature from the bank. And if that's correct, then Bob can give Alice a sandwich. In order to redeem this, Bob gives this coin to the bank. The bank says, okay, I've never seen this secret number before, so I'm going to assume that it's, and you have my signature on it, so I'm going to assume that I went through this process with somebody and, signed something, and now I'm going to record that secret number. Once that happens, Bob can be sure that this coin hasn't been spent before. The bank keeps a running list of all the secret numbers it's seen, and it makes sure that if it ever sees one again, it can say, no, this is not correct. I should never see a secret number more than once. Now, okay, but what about Alice could give a version of that to Bob. Alice could also give a version of that to Charlie. And how are Charlie and Bob supposed to know whose coin is correct? Because remember, we wanted to try to get the bank out of the way when doing this. And so in Xiaomi and eCash, the way that this works is the bank actually keeps a bit more information, and the information that the bank is keeping won't let the bank link these transactions together unless Alice happens to give this to two people. And so if Alice gives the same coin to two different people, the bank will be able to detect it, and the bank will be able to know it was Alice. And so this is kind of a motivator for Alice not to do that. So the idea being here is that the way that we get around the fact that we don't know if a coin has been double spent or not is we add punishment if the coin is double spent. So Bob doesn't know for sure that this coin he receives hasn't been double spent, but he does know that if it was, someone's going to know it was Alice, and they're going to punish her. So this is a pretty clever scheme, and this actually gets us around a lot of problems. We have digital payments. We can make the actual transfer without the bank in the middle. We have some privacy now because the bank can't link transactions together. And we have this way of doing double spend detection. We have a way of motivating people not to double spend their coins, which means that you probably don't have to check at the time you receive a coin whether or not it's been double spent. Of course, this still suffers from a really big problem, which is that a bank can still decide that they just don't want to do this with you. They can just decide that they don't want to play this game with you. They don't want to issue coins. They don't want to, maybe they don't like you specifically. Maybe they don't want to take your coins and exchange them. So this scheme, Xiaomi and eCash, solves quite a bit of problems when it comes to how do we have electronic money with some nice features, but it doesn't quite get to all of them. And so the real question in this class is how do we do electronic money really in a peer-to-peer way where there's no institution in the way, there's no sort of entity that can say no.
So eCash is